graph. And what I recommend every time there's a question with a graph, you analyze the graph before you read the question and get distracted. And this is where our process of Oizerga is very important. Oizersa. So the origin. We want to look at the origin. And so we look over here, we see an even scale. 1, 2, 3. And so this is 0 on the x-axis. On the y-axis, we have 6, 4, 2, 0. So this is indeed at the 0. So we're 0, 0, and we're right there. It's where we're located on the coordinate axes. Then we look at the y-axis. It's position in meters, and the scale is it goes by 2s. There are no error bars. The x-axis is time, and it's in seconds, a normal unit, and it's an even scale. It goes by 1, so this is a very simple graph. Well, the things we can read are the axes. So if we're asked a question about either position or time, we're just going to read the answer off the graph. Now the slope, delta y over delta x, is delta x, change in position over change in time, which we should recognize as the velocity. And it has units of meters per second. So this is velocity. It's a big deal. So, oops, this one's velocity. So if we are asked about velocity, we're going to be thinking about the slope. If we're asked about position or time, it will be reading. And the area is multiplying the axes. X times t, that has units of meter seconds, and meter seconds isn't a quantity. So the area has no utility to us. All right, so now we have analyzed the graph theoretically, and now we look at this and we see, all right, it starts here at 0, and the value of the position is increasing. It looks to be increasing at an increasing rate, and we could say that because between 2 and 3, we have this delta y, and between 1 and 2, we have this delta y. So the slope is increasing. So we can see that there, what's happening. All right, so now the graph represents for an object being acted on by a constant force, okay? The average speed during the interval between 1 and 2 seconds. So between 1 and 2 seconds now, 1 and 2 seconds is this. So that's what they're looking for. They want the average speed. Well, the definition of the average speed is the displacement over the change in time. So if we look at the displacement, we ended up at 8, and we were at 2 at the beginning, and it occurred over 1 second. So that looks like 6 meters per second. And it turns out that is also the slope if we connected those 2 points, delta y over delta x. So that's why we have an answer of 6.